Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. Today we will continue uh, the thing where we left off. That, if I remember, was that we implement some usage code for what could be our lexical scoping, and yeah. So please, if you have any questions about the project, any inquiries, feel free to ask them. You can post your questions on Twitch, Twitter, or Twitter. Twitch. What is it? Twitter and YouTube. And since we don't have, it's been a while since we don't handle Twitch for some network reasons problems that we got. But you can post them on Twitter or YouTube, and I'll be there to answer. So with that in mind, I would like to start opening the project. EagleFly code, okay. So let me see if we compile. Yes, we do. And I will open the debugger. Not the debugger, but Visual Studio's debugger. And let's see. So let me see where it was. What with Visual Studio opens. Well, now it seems to open. We can try to do this stuff. Okay, this open. And as we see, we have our a little window here, and we yeah, so that's the thing that we left off. So let's see if we can continue on the thing implementing the elliptical scoping. So let's go to the tracer, and it should be here. Here you go, here it is. We have this thing that it's called construct lexical scope, and basically it's a tool, it's a way that we define for us to find a way, like this is like a first test try, like, hey, we want to construct, I mean, for example, the user is going to stop here, and the stop tells us, hey, I want you to stop on a specific instruction using the EIP instruction pointer for us to see, okay, this is instruction where he wants us to stop. So we want to do something at the moment in the place. For example, some of the important things that we want to do is to show the register. So we can see x64 registers, x32 registers. We can see segmentation, memory segmentation, all segments, code segment, data segment. Probably, I mean, that would be pretty much a really good thing to know about the code, So I think it's well, that's the first part we have here, and the second part is more related to source code. That's the part that we were doing here, so that we have a lexical scope, and the idea of this lexical scope is to construct it based on one, the PDB symbol information that we parse and extract from PDB files, and second, to have some kind of mapper between assembly code and those symbol informations, those PDB symbols that we extracted, so that we can have like this kind of unified image of the target process that's running, and that's, and talking about that unified image is like the, how can I say, it's kind of our target, or we're aiming for trying to construct that image, and the image, like, hey, I want you to post all this data out, in this way. Probably, I want to construct this information based upon data that we can get somewhere. That right now we have PDBs for first, but we should also take a look onto image files themselves and to the process itself, and that's something interesting. I mean, the image file is some kind of how can I say, yeah, it's gonna have something, it's gonna have like, let's say that we have like a first glance into what the process itself has itself, but of course it's not the same, that's why it's called an image, since image files have the base image to what in the memory is gonna look like, so it's like a memory image of memory itself, so an image file, it's an image to memory. I mean, an image of how an application looks in memory once it's loaded by the loader itself. So that's our first glance, but of course it's not sufficient, because the process itself transforms itself inside itself. The process transforms itself. Yeah, I mean, it sounds crazy, but that's how applications work. Every time the processor, it's moving memory in and out, transforming the data inside itself to new and useful data transfer constructs, so that's the whole point of it, and we would like to have an image of that thing as well, so it's a kind of that's what we are looking for, to find a way to do that. So okay, so let's see. So now that we have that, I would like to, I think we have it here. Yeah, we just define the whole symbols, the whole functions in here. So for what a lexical scope means to, let me put it right here. A lexical scope could be defined, and we put it right here on No, it's not here. It's on info. We define all these new, like, we transform these structures so we can handle lexical scopes. One of the things we changed is that pretty much we kept like this kind of nice and flat thing that basically has all the disassembly as a, as a table. Well, I mean, it's a table, but it's a double linked list here. But it's totally flat. It doesn't has any kind of branchy stuff. The EagleFly symbol entry by the other side could in itself could have some kind of way to have that branchy stuff. Right now we don't have like some kind of we can have like a parent itself, so we can go backwards like pretty much easier. That's something we don't have. We should like we could try, or the reason that I didn't put a parent is because we don't know how we're gonna like be moving around the data itself, that's why I keep it flagged, so that it's such easier. Of course it's gonna take a lot more time to do it, but it has this practical nice way that if we don't want to jump or we want to see like the whole stack, as for instance, we can go and check each time how does it's pretty much similar. Let me draw it so we can see here. For example, well, I'm gonna do something similar to this. I'm gonna put it here. And I don't know what day is today. I think it's day 61. So the idea that I have for the symbol information itself, it's something that works as self tables. One is the lexical scope table, and the other is the assembly code blocking table. And I mean, they relate to each other, in several ways, but both the ways work in pretty much the same way, I guess. The idea of it's that we can and now I think about it, what I'll have here. We have here previews, I guess. And the way they relate each other, it's some kind of an indirect way, so that for example we say that we have a ACB, let's see, like assembly code block. The idea of assembly code blocks is that pretty much map directly to what a LexicalScope could do, or LexicalScope could have. So it can be like a stack, that pretty much has all the data information that maps to a series of instructions, C++ instructions. For example, let's say we have I don't know, I'm gonna write here like this. This is our LexicalScope, it can be a function, it can be a block, it can be a thunk, whatever. It's gonna be our block, and this block has a series of instructions, some kind of block instructions, that we're gonna have that data, you know, we're gonna have that symbol information, so we can display it itself as the data, and we're gonna have the symbol data information for the source file that's gonna map directly to it. And so we'll need to see if this is like the best idea to implement this kind of stuff, but we have to see and test it, and probably we're gonna need some kind of way like to identify, because right now, as you see here, we have like this indirect thing. Like, I mean, pretty much everything is gonna work. We're gonna start by this. Look, I don't know, the user has an EIP, and of course that EIP is somewhere in here. You know, it can be here. If it's here, of course, it's in another code block. You know. So now I think about it. Oh no, I forgot that it's this one. We can have some kind of this way, and we can call it child parent, or can be next, or but I mean, this is the idea of it, you know, so that we can have some kind of symbol stuff that relates to both EagleFly lexical scope. You know that I see you have a where is the lexical scope index? Here's the scope index, and we can have this is as a code block index. So I don't know if code block index and scope index should map exactly to the same one. For now, we can say that yes. The only thing that I'm thinking through is that we want to have some kind of that. I mean, I don't want to have duplicate of information. So, well, this could be, I mean, this data, let me put it here, load Alex. This data, it's the captures scope independent and what I mean scope independent is that it doesn't capture for example, if he has another block inside this block that would be like this, you know, like in next, it would be in the next one, you know, and you know, and it will be continued like in that way. So I mean, it's the same idea, you know, if it goes through the disassembly code block or if it goes through the lexical scope. I mean, you can go parse the thing, I guess, by the same way. It should be mapping to the same, well, not the same data, of course, but in the same way. If we can see it that way, you know, I mean, probably we can and that's the construct lexical scope job to do, like to have like to construct this mapper between this assembly code block and lexical scope itself. So yeah, I think we can do it that way. So now we define like these kind of special cases where, I mean, each data for the EagleFly function data or thunk data, block data, or struct class data, I mean, it's gonna have different you know, different data itself, you know, since there are different constructs. Yeah, so lexical constructs. So yeah, we have to see and check what we can insert in here, but I think we can have some kind of this thing going on. And so I think, yeah, and I was like thinking, well, yeah, the symbol entry, I don't know if we want a symbol entry itself for the lexical scope that will need specific data to it, which I think we could, you know. And the only caveat with that is that we will need to, I mean, if we want to like kind of to look through both of it, I mean, we have to, I mean the most problematic thing here is like everything will be done serially, you know, like, I mean, that's not a problem, but it's just like we have to look through all of them to find it, you know. I mean, we probably want to do something better there, but for now I'm gonna keep it that way so we can see like how all it goes and see like each I want to see the whole step processing of the process itself, so we can find like this kind of good system that gets from it. So I think I can do something like this: EagleFly symbol entry, symbols first, I'm gonna put this right here. I'm gonna do, where is it, first symbol, guess, you know, and well, it's gonna be another block, I guess. Symbol block, symbol block, symbol block. Where is it? There you go. These are sketches, blah 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 blah. We have some EagleFly target architecture there, which is nice. EagleFly compiling modules, and we have, and this is per module, you know. I mean, we have a disassembly and the lexical scope going in parallel, and yeah. So now I think about it. Let's see if we try this one. I mean, I know it's a code block, but it's code index. Or I'm gonna call it yeah. Yeah, I mean it doesn't exist here. I don't know if I call it stack index, stack. How many times the stack has been pushed? How many times? Yeah, because it's different. I mean, we can count on that, but we can do something more like this. Something like that. And I don't know if, I mean, I don't know how many scopes we're gonna have. 4 billion scopes. I think that's sufficient. I don't know. I mean, I don't know. Probably. I mean, you cannot like totally assert that. But we can try. EagleFly decision code block. EagleFly target architecture. There you go. And you know, the thing that this allows us is that I mean, we can like, even though we know that, and probably this is called more like ID itself, but I just wanna keep it that since they're mapped directly, yeah, we have to. I mean, just because this is implicit, it's not here like explained, but I'm gonna put it here. And probably this assassin code block probably is not if like code block can work it. Or up code block, probably that can work. So I'm gonna call it next prep so that we can see. And if you think about it, yeah, probably it's missing something here. Like, I mean, because this just tells us like, hey, we want to go like deeper each time, or we want to go outside of it, but there's no way to go like onto the next lexicoscope, for example, so that that's something interesting. I mean, if you want to like change between lexicoscopes, we cannot do it right now, and that's something we can have it. I mean, we can have like this. I mean, both ways, you know. Which probably I was just thinking like, well, we probably don't need to go to the next. I mean, what we can do is to let, I mean, everything is gonna work like in opcode block, you know, like it's this fast way to go between blocks. But now, since we know that, I mean, we have to keep track of the EIP register, so we can see basically how everything is connected, you know. I mean, if you think about it, let me go, I don't know if it's gonna compile. This is this. Okay. Well, let me solve first these compilation errors so we can continue. That's all. Okay, we compile. Okay, so now, yeah, what I was gonna say is that we probably, I mean, since we don't know quite clear how do we want to do this kind of stuff, we just like kind of implement it right now. Like, I say, hey, we have this. Yeah, I mean, probably now that we have like at least some spec, I want to go back to gather that data, and now this data is gonna have some special characteristics. For example, let me see. And these are the ones. For now, yeah, we're not gonna care too much about the next ones. Right now, I'm just gonna like create the call stack or something, you know. It's like, let's focus on that, and later we're gonna like focus on how to connect that to the next like thing that connects to the next lexicoscope, let's say. For now, we don't care much about that. So this will create, let's focus just about that, gathering the call stack and displaying the whole call stack, you know. Well, I mean, probably, I mean, well, before calling the call stack and stuff, let's gather the instruction, or the let's say where the EIP is, at least. That's the first thing we have to do. Just, and yeah, that was the first thing that we think about it, but we just want to say we just want to see a little bit more of it so we can construct it, you know. But now that we don't know pretty much more about this, we should go and do it, you know. So now I would say something like, I would say something like, let's construct this data. And for constructing it, we have, yeah, now we have a question about, where is it? We don't have the load image thing itself. It's just say, hey, we don't load it anytime. And now I can say something like this just for testing. And what the load image is gonna do it's gonna basically initialize the process where the target process is gonna run into. We say that we want to run it with the debug only this process, so that we only debug this child process. We don't debug any child processes from the child process that we are creating, you know. And that's for the starters because that's for simplicity. So we had this, and we have this call that we define here. That's basically we try to load debug info from PDB. That's basically our callback to the PDB parser. We can go. It's not here. It's the other one. This is a PDB parser, and the PDB parser is gonna basically construct this whole data that we define here. So right now, I mean, we have like some kind of good indices of what does it should have, you know. And the thing that I would like to do now, it's before I would like to define a way like let's say that we inside the tracer we have something like we have this thing like every time that the PDB full path gets changed, we compare it and we load the image and we load the image back again, which is nice. And I don't know if the target itself or the image itself, I mean both of them I guess. I don't know, it's target image full path. Compare file time. And this is like, yeah, this has a problem because it could be that, for example, we start with a PDB, but then the user decided not to have that PDB another time, you know. So although it's gonna, I mean, it's not gonna have a problem too much because the loaded image itself is gonna do the work of checking back that PDB exists for this image. So it's gonna, so probably we can do it like this, I guess. Alright, so now that we do that, like we unload the image, we load it back. So now we can try to construct the data that we supposed to have. And now we have like this callback. For now, I think we're gonna keep it that way. It's just gonna work as the for now it's like it's gonna work directly in line with it, so it's gonna have like this glitchy thing, but we can do something like putting it in another thread, I guess, so it can work in parallel, so we don't lose some time there for rendering. And yeah, so let me see if we can say something about this. So now the first thing that I'm gonna do is I'm gonna say something like this, and I don't know if I erase the other codes that, well, yeah, I erase it, but it doesn't matter. Now the first thing I would like to have is a way to know the module that we're looking at. We know that I mean, that can be stored on, let me see if this has any kind of information on that. Let me see. It's not here. It's right here. I mean, we know that the PDB itself has the module information for whatever we are at, but the process itself, I don't know if the process, yeah, I mean the process should have, but I don't know where. That's the question. So we can start by this. We can start saying something like we already have it, isn't it? I don't know if this has the low DLL. We have the base of the DLL. I think it should be, we have the base of the DLL, we have the handle to the file, and we have pretty much, we should make a match, between the symbols that we got from the, and we don't have those symbols, doesn't it? We could, we could not have those symbols for DLLs. That's what normally happens when you trying to debug something and it's not there, So that's kind of tricky. For now, I think we're gonna just of course not gonna touch them, but if there are some symbols for them, like a DLL that you created itself, that's something that we can debug. Now let me see what other information do we get from there. Oh, here it is. Here's the thing that we did. The first thing that was our first test. So Okay, so I want to say something like this. Let me see. I'm gonna, of course, we have the memory. We are gonna imagine that we have the memory, and we're gonna say something like, for now we don't care. I'm not gonna care about the modules itself. We wanna have that, but for now we're gonna set. We're gonna do something like this. For not complicating us, we're gonna keep it just for one module, since we know right now there's just one module that we're gonna spec into. And for now, let me keep that like that. And here's the thing. Now I'm gonna have some kind of a this day debug info. Well, we can say I don't remember which was we had it here, isn't it? Debug info arena, and this debug info arena is gonna have some way for us to get that data. So we have to take this and we're gonna assume that we have it. And then I want to do something like now we get the memory, and now we can go directly to the find out the address for that, and it's gonna be pretty much like debug info opcode sentinel, and it's gonna be EagleFly opcode block. Yeah, opcode block. We're gonna do something like that. And then we're gonna do something like opcode oblock. And I believe we already have something similar here, but I don't remember. It was this. Yeah, I think we should change it. I mean, it was like some kind of first idea that we got there, but it doesn't matter. So if we have if O block O black and yeah, we have, I mean, it's gonna be like similar to this. Let me copy it because this is useful. It's just this line of here. Simple transformation here. And now we have, yeah, we have the address, and we have, instead of line maps, we have O block. There we go. We're gonna do something like this. And we can even how can I say we could have something like, oh, we need this, we need this, we need that. Like if we wanted to construct the whole thing from the start up, yeah, we will have a way to do it, because we just need to, I mean, every time we're going down, we're going deeper, you know. So it should be something like every time we go no block next, this is going deeper and deeper and deeper and deeper and deeper. So yeah, and whenever it goes outwards, it's gonna go we'll think like it's gonna go out straight away. Which I think is nice. So yeah, I mean, it can go that way. Of course, it's not gonna have the next one, but we're gonna implement that just after this. So it's gonna be, I mean, we can do something like an operand pushing, you know. So like we construct the whole push track, or we could go the other way around, you know, so that we could go this way, like, let me see. This is kind of a good thing to have, like like instead of doing it in the loop, it would be nice to it being iterative, or how do they call this in to construct the stack itself. So something like this. Although it would be just so yeah, I think I'm gonna do it that way, so we can take a look into that. So something like this. And probably we don't need this. And I'm gonna do something like construct lexicalscope. Or I'm gonna do the same. Push tag. I want to say something like this. Probably I'm gonna do this, and this should be here, and right here I'm gonna do something like we have a dispatcher state, the memory index, we have a opcode block, and I say something like or block. We can pass the sentinel itself. recursive. I forgot the word, but yeah, this is a recursive mode way of constructing the stacks, which is pretty it's gonna be a little bit it's gonna be less efficient than if it was for with if it was done without any recursiveness, for example with a for loop. But yeah, I mean, we could change if we see that it's like totally not the thing that we want. We can change it back to a for loop and we can see. But for now, it's okay. So let's see if we can. Yeah, we pass the sentinel, we pass everything, and we're gonna continue pushing up the stack every time. So if we do this way, so for example, if we have a number between, we're gonna say that we're not gonna push the stack anymore, and we wanna construct the stack based upon that, because we already constructed back. So we just wanna see every time what the opcode cell has been done, so we can use it. So we can say something like push struct, and we can I'm gonna push struct how is called this EagleFly LexicalScope, and this has to be, I guess, the thing that we return. We can put it right here, I guess, so we get it, but I mean, I don't know if we want to. Let me see. Let me think about this. We can construct it and return that as the root, or we can construct it and return the root to be joined this way. It can be like some fancy thing here, like since we know that it's gonna be like this. I mean, it's gonna go like we have the root, and it's gonna be like going recursively downwards until we get something. If you know this is the one that we were looking for in the LexicalScope thing, so we already have this kind of blocky thing. So we just have to construct it based upon the others. So we just like connect this one to this one, this one to this one, this one to this one, and the block will be connected. That's one way to do it. It will be something like this. This is a double linked list. Is going to be like connecting all together, and we just return this one back, so we can just look back. That can be a way, or we can return this one, and this is like the leaf. Since this is the instruction pointer that we're looking at, this is where EIP is. Probably we want to get onto that. I don't know. I mean, both of them can work. It's just that the convenience of where do we want to. We know that this is the context. We know that this is this is the point where we are at on the process. But this is the root, and the searches will be like, there could be linearly, so it doesn't matter. So yes, so it's something like, and just because I want to say it, it's going to be something like, I want to do something. We already have a way to do this on the platform layer. Let me see. We have it in the PDB. Here. Here's the thing. we want to do something like this. So we probably want to say I can even do something like this. For that, we don't want to do anything like this. We just need to pass block or whatever you're passing me. You can say something like that. And this is gonna be, oh my god. This is a tail dealer. It can be. don't want to confuse with the DLL, so probably we want W. I think I like it this way. So that seems to work fine. So now I just want to say that I want to pass this onto the platform layer so we can make use of it. And I want to say, just since we're like adding too much of it, in a double list, so now that I have them, I would like to say that we have in the info, I would like to say something like init I think I'm gonna say something like on the dispatcher, where is it? This is gonna be something like that. And I want to do this outside here. And I'm gonna add to tail. Now if we add to tail, it's gonna be Yeah, it's gonna have the order that was looking for. Okay, perfect. Yeah, it's gonna be this way. You know, this is gonna be the Oh, okay. This is gonna be the sentinel. You know, and it's gonna go straight onto their outside. You know, to the stack, which we're gonna see if that's the most useful way to address this. And yeah, so let me. So the thing that we would do here is I'm gonna push a struct for the lexical stop onto the arena. And it's called debug info arena. And now, since this is like it's something that we already like kind of constructing, and we probably want to keep it. I mean, we don't want to lose it every time. And I think about it. I was like, yeah, we don't want to lose it. And now I was thinking like, well, probably we don't want to do this explicitly. Every time we continue tracing, we probably want to keep it the lexical scope, so we can use it every time we stop. You know, and only if we, of course, every time we will need to there's a two side of it. Yeah, we probably want to keep you know, like some kind of display that allows us to kind of let's say a breakpoint cache, you know, so that every time we cache, we know we probably want to do something like this. How can I call it? Make a list of breakpoint lexical scopes storage, so that we can reuse them. We don't need to create every time. Yeah, for now I'm gonna keep it that way, but yeah, it's something that we wanna do. Make a list of breakpoint lexical scope storage, so that we can integrate. And if that's the case, we just, let me see, because we have a dispatcher state, and that's probably it's kind of, yeah, I'm thinking like where in memory should be, because right now we have several memories, and each one has its own usage cases, you know. And since now, like, I mean, we haven't defined yet, like, I mean, where everything should go, and we're just like dumping everything so we can see what's going on. Right now we're dumping everything to the dispatcher state that has an arena that we can use to pretty much leverage everything that we are gonna, everything that we need. We're gonna get it, and we're gonna reset it every time we continue, you know, which I mean, it's not super interesting, but it's something that's it's useful for, at least for now. But we have to see like how everything goes. We probably, because we already have like in EagleFly, let me see, EagleFly, here we go. I think here we have yeah, we have a debug arena and a transition arena. I don't know, I mean, we haven't used anything of this yet, so we can, it could be useful. I mean, probably later all this data is gonna like be dumped into there, you know. For now, yeah, it's, I mean, it's kind of hard to do that right now, so we're gonna keep it that way, I guess. But yeah, it's gonna be make a list of very complex scopes. Okay, yeah, yeah, and to do there you go. Yeah, something like that. Okay, so with that said, I would like to continue. Now that we have a sentinel, we're gonna construct it backwards, you know, so that we can see it in that way. So the thing that I was like trying to do here is like, yeah, we're gonna push a struct into the debugging for Reno, and that thing is gonna basically work as it's just like boom, dumping everything that we need right here. So it's gonna say something like, hey, just give me in fact, I mean, just because why not, I mean, I'm gonna I wanna do something like this. And in fact, we can say something more like this. Tuesday lexicalscope found there you go. Then we push it, and then well, we can do it like this, I guess. And there you go. I think that's it. this will make our linked list with all the scoping thing happening, and we can even if we wanted to, we can make two of them, so we can because we are in one, I mean we are using the O block, but we are not like making the O block anything like being dumping into it, yeah. But the O block, it should be already set by the constructor. We just, in fact, I don't know why where is it? In info, I mean we have yeah, we have this, but this is not something that's going to be filled out by the LexicalScope itself, yeah, something more like this. And of course we wanna get it somehow. Right now, okay, we created it, we have it, it's there, we have all of them joined together, but there it doesn't have any kind of relevant data within itself, you know. And that's a kind of the thing that we could go within and do it. So I think, oh my god, I mean we can construct it and okay, this is probably something different, because I mean we can, I mean this can be done by the PDB parser, so that we just, I mean we are gonna get like the whole thing, we just have to go directly to it, if that makes sense. I think I like that more, because if you think about it, I mean that's the whole point of having the PDB parser get us some kind of some lexical scoping being defined itself. So I mean I'm not gonna erase this, because this is probably something that's gonna be done by the parser, but this is gonna be so I can even move this to the parser itself. I want to say something like something like that. So that, yeah, we will have something like this right here. So in this sense, what I will need to do is something like the thing that we were doing before this. So it's gonna be something like this is gonna be Sentinel. So the thing I'm thinking through here is that I mean, probably we want to have, and it's not necessary, but I think like probably we can have a way to access it by arrays, you know, so that we can just say something like this. And we can do it both for the both ways, but for now I'm gonna do it this way, and we can test. So scope 0 is gonna be the root always. We're gonna say that. You can say something like that, and there you go. I think that's the main point of it, you know, so that we have some way of doing it. And I mean, the caveat with this is that it would be super if it's not if data fetches are not aligned, it's gonna be super slow to do this. So probably we want to align this. So for example, if our lexical scope, I don't know how much size of this is in right now. We have pointers 64, 32, 32. So it has to be 64, 64, 3, 4, 5. So it's something like 320. So probably we want to align this to that, or we have to have some kind of alignment there, which is that's the caveat. And of course, I mean, that's if we wanted to have this fast way, because now we will need to iterate every time back onto it. But I think we can do it this way. So I mean, we can define if it's 320, it has to be something like 128 times 2. It should be 512 something. To the next power of 2 greater than size of it's 512. And if we want to do something like that, we'll need to I would like to say something like this. You know, and it's super simple. It's gonna be I don't know if you wanna handle such a big, like 4 billion size page boundaries. Probably not, but um, or 4 gigabytes page boundaries. I don't know, but I'm gonna do it like that. So we're gonna do something like so. Or so size less so I mean I don't know, it's gonna do something like this. And let's Let's see, let's compile this. I'm not gonna do this, but this should be here. No, sorry, this is editbook info man. Oh yeah, this has well, we can do something more like this, I guess. This should be if you're looking for ma'am, and this has base. How do I call it? EagleFly became okay. EagleFly optical block. current lexical scope, current lexical scope, current lexical scope. Well, now think about it, we don't need this right here. And we don't need to this has to be something like that, and there you go. So if we run this, of course, just for testing, we're gonna have some, I don't know, we didn't do pretty much, but it was something like here. There you go. We're gonna initialize, we're gonna get everything done, we're gonna enter to the load image, we're gonna try to initialize the process, and then we say, hey, we got a problem with the begin time memory. Oh, okay, that was stupid. Platform begin time memory, we don't want this, of course, because of course it's not gonna do it. Just gonna say arena used. And there you go. Okay, if we continue back again, let's try this one more time. We're gonna begin, there you go, and there you go. Well, we're gonna not do anything of that because we haven't done anything with that. We're gonna try to load it, but it's not gonna happen anything. Process is running, it's not gonna happen, and there you go. And continue. Okay, so that was good. And yeah, I think we're gonna continue with this on the next stream. I know it wasn't like a lot of things to do, but we will continue this. And right now we have we start constructing this idea of how do we wanna get the symbols and how do we want to construct the symbol data information out of it. So yeah, I think that was good. And please, if you have any questions, you can post them on Twitch, Twitter, or YouTube, and I'll be there to answer. For now, I think that'll be all, and I'll see you all on the next stream.